Hello everyone, I hope you're doing well. Before we get our hands dirty for this tutorial, let me clarify the workflow so that the procedure would be crystal clear when we work with families and Dynamo. For this tutorial, I'm gonna use a metric generic model where I'm going to create my single panel and parameterize it with the parameters that we are going to need later on in the Dynamo script. Then I'm going to load it into the geometric generic model pattern based and placed it and set up the same parameters of the metric generic model. And then we are going to load this pattern inside the conceptual mass where we set up our facade panels and pattern and select the pattern that we created in the family of metric generic model pattern. And then we are gonna actually select a single point where which is our attractor, and through a Dynamo script we are going to select both families inside conceptual mass and our point. And set up our Dynamo script so that the panels can be parameterized and the ultimate goal of this workflow would be a parametric panel, as you can see in the right image. For this tutorial, I'm going to use Revit 2024, and all the nodes inside Dynamo would be out-of-box nodes, so you don't have to install any external packages for the Dynamo. Now let's get started. Let's start with a new conceptual mass family. All right, I'm gonna make a rectangle. So let's start with the line and create form. Let's adjust the height and length of the, let's say, our facade panel. I'm gonna set this to 30,000 for the height and 12,000 for the length. Already we can apply the dividing panel surface on this facade. Let's do that, and I'm gonna set this fixed number for the U grid to 20 and for the V grid to 8. Cool. And now let's start with a new family. Let's search for metric generic model pattern based. And now let's set the grid to 1500 for both grids, for both horizontal and vertical spaces. Cool. Since I found it really difficult to parameterize the family inside there, I'm gonna look for a generic model family and nest it to this one here. So let's start with a new family with metric generic model. And I'm gonna add some reference plane here so that we can start modeling our panel. Let's start inserting some dimensions here and make it equal for both vertical and horizontal references. Cool. We can basically set it to 1500 for both sides. So, oh, sorry. If I can get this number here, right. I need some other references to make a hole inside the panel. So I'm gonna add other two vertical and horizontal references. And it's the same dimensions, make it equal. Awesome. Now we can start creating our extrusion. Remember, lock all these lines to the references so that they can work properly. And the inner one. Awesome. Let's switch back to 3D view and see our panel here. Now we can add some parameters to the length and height of the panel. All right. So for that reason, I'm going to select the dimension here and add a instance parameter. I'm going to make it like length as an instance, and this one as well. I'm going to name it height. And we need another parameters to control the thickness of the panel, right? The thickness, I mean, in this direction. So I'm gonna make another dimension here and name it X thickness, always as an instance parameter. And the same for this side as well. And let's apply this one. Awesome. Let's go back to the 3D view and look if each parameters work properly. Let's set this to like 100. This one is working. And now I'm gonna insert another parameter to control the height of the panel. Let's switch to the left and insert a reference plane. I'm gonna select our panel and lock it there. Cool. And now we can actually, let's search for the plane. All right, reference plane. And now for this one, I'm gonna make a new parameter and name it Y thickness. Cool. Let's test this out. I'm make it 500. It stands to be working. Now it's time to load this family inside the pattern, okay, which is a family 16. Let's place this one here and switch to the top view so that we can align our panel inside the grid. Activate align command and align the pattern and lock it there. Here we go. Select the solid, our panel, and we need to actually assign the parameter inside this family here. So I'm gonna click here and make a new parameter and name it the same. For the length as well. And the last one. Here we go. Now we can test the parameters inside the family to see if they're working properly. I'm gonna let's change it to 500 and this one to 100. It sounds to be working properly, and it's time to load this pattern inside our project, which is family 15. So let's do that. We can select our grid and change the pattern to a family 16. Alright, now we have placed all the instances inside our panel here. Now it's time to start with Dynamo. Before that, as an attractor point, we can place a point inside there and uncheck this driven body by host so that we can basically change the position of the point there. All right, let's start with Dynamo. For the very first node, I'm gonna look for family type and select. Before all this, let's say, switch this one to manual, and I'm gonna select our family, which is family 16, and we need all the elements inside this family. I'm gonna search for all elements of family type. Let's hit run. So we get all the family instances of the panel, and now we have to search for the location of each panel here. So I'm gonna search for element.getLocation. Cool. And now we have to select the our attractor point there. So I'm gonna search for element, actually select model element. Let me select the point there. All right. Since it is the Revit element, we need to translate it or convert it to the Dynamo space element. So for that reason, we need to search for element.geometry. Let's hit run. Here we go. In the backspace of the Dynamo, you can see actually the locations of the each. Let me zoom a little bit there. Here we go. Let me set it here so that we can see what's going on there. With Control B, you can switch back to the Dynamo nodes. And here you can actually uncheck preview geometry to don't see that in the background of the Dynamo. However, I'm gonna leave it for now. It doesn't matter. So we need to search for a node. Through that we can measure the distance between the this one for each point of the location of elements, right? So I'm gonna search for geometry dot distance to which requires two inputs, the geometry and the location of our attractor point, right? So now let's hit run. As you can see, we end up with the with just one output, but we need a distance for each single panel. So I'm gonna check this to longest as a lacing so that we can have all the distances to each point. Let's hit run, and as you can see, I've got all the measures here. Now for the remapping the ranges, we can use math.remap range, and with the code block, I'm gonna remap all the ranges. All right, the ranges that I'm talking about are the values of those two parameters, x thickness and y thickness. So let's bring out a code block here, and for the x parameter, x thickness parameter, I'm gonna search 100 and 400, let's say, or even like bigger, 500. And for the y thickness, I'm gonna set it to 100, and let's imagine a big number, 1500. Cool. Since we are working with two parameters, we can have a couple of these nodes here. All right. And here is my minimum and the maximum of this parameter, and this one I can connect it to the to this node to remap my ranges for the Y thickness parameter. And for the very last node, I'm gonna search for a famous nodes element dot set parameter by name. Okay, and now we can have actually a couple of these one. Let's copy and paste it here. Cool. As the element, we have our panels here, as you can see. So I'm gonna wire this to the element input. As a value, we've got all the values and ranges here. I'm gonna connect this one to this and this one to this one here. And now we need to look for our parameter name. So I'm gonna add the code block in there, and let's say let's write the name of our parameter. All right, and the other one. Cool. Let's connect this one to this one, and this one to this one. So I think we are good to go, and we can hit run to see the results. It seems to be working. Let's switch back to the Revit and see the facade here. And to switch off, turn off the our point location, you can hit this button here. Don't see that. As you can see, the nearest panel to the point have bigger hole and they are thinner, and the one, for example here, this one has actually a smaller hole in there and it's thicker. So let's test this one and change the location of the point. I'm gonna put it in there here. Switch back to the Dynamo and hit run. Perfect. It sounds to be working actually. Respectively to the position of the attractor point, the panels are changing properly regarding our values which we had indicated. I hope you enjoyed the video. Have a good day.